Alrighty, so we're going to want to find the equation of a line that passes through the two given points. Alright, so there's one way that you could do this is you could graph both of these coordinate points, connect the 2 points, and then see, go and count rise over run, and then find the slope, and then look and see where it crosses the y-axis. You can do that, and just so that you get a visual. But what I want to show you is how to do this algebraically without using a graph, without using a coordinate plane, and how you can do it just by using algebra. All right. Well, what we've been using in these examples here is we've been graphing lines in slope-intercept form. Y equals mx plus b. Okay, where our m is our slope and our b is our y-intercept. Okay, so check this out. If I want to find the slope, I want to find the slope of an equation. We've learned in example 1 that you can find or actually I think it was last section, section 3.1 or 3.2, we can find the slope between 2 points. And that is, if you want to find m, you do y2 minus y1. y1, that's a funky looking y there. Let's try that again. All over x2 minus x1. All right, so that's what I want to do now, is find this slope here. So I'm going to do y2 minus y1, so 4 minus 6, and then x2 minus x1, so 1 minus negative 2. All right, and that's just going to give us 2 over 3. Okay, so 4 minus 6 is negative 2 actually, and then 1 plus 2 is going to give us 3. So we just found m. Cool beans. So check this out. We have y equals negative 2/3 x plus b. So we're halfway done. So now how do we find b now? How do we find the y-intercept? So check this out. If I want to find b, I choose one of these 2 points. It doesn't matter which one. Negative 2, 6, 1, 4. It does not matter which one. I'm going to choose one of them. And I guess I'm just going to choose this guy right here. All right, so if I choose this guy, what I'm going to do is I'm going to plug in 1 in for x and 4 in for y. Because this x and this y is going to be on this line, and then I only have one variable to solve for, which is b, and then I can go ahead and solve. So that's what I'm going to do now. I'm going to go ahead and solve this guy now by doing some substitution here. So instead of putting y, I'm going to put 4 negative 2/3 times x, which is 1, and then plus b. So check out what I just did here. I took the 1, 4 and plugged in the x for 1 and 4 for y there. Okay. And so now let's solve for b then. So 4 equals negative 2/3 times 1 is just negative 2/3 plus b. Last step is just go ahead and add 2/3 to both sides. So if that's gone, so b equals, you might want to do this on the side here. So 4 plus 2/3. All right, so I want this to have a third as well. So I have to multiply that by 3. So that 3 times 4 is 12. 14, so that's 14/3. Okay, and I'm glad that we didn't do the graphing approach, because it would have been very difficult to try to guess that the y-intercept was 14/3, right? It's going to cross over at a decimal point. You're not going to be able to tell what it really is. So this is where the power of algebra comes in, where you get precise numbers here. So we have a y-intercept, we have a slope. So now we can write our full equation. Y equals negative 2/3 x plus 14/3. So something that you would not want to try to do by looking at a graph. Okay, so there's that guy, and I have an example b up here. So let me just move this guy down. I thought we were gonna be able to let me just cut that guy and move it down here. All right, so let's go ahead and try now example b right here. All right, so we're going to do the same thing. We want to write an equation in slope-intercept form. And so we wanted to make it look like this. Y equals mx plus b. So let's first find our m, find our slope. And actually, you need to find m first before you can find b. That actually is the case every time here. So unless you want to try graphing it and see if you can figure out what the y-intercept is. Alright, so it's going to be my y2, so negative 1 minus negative 4. So y2 minus y1 all over x2 minus x1. Okay, so I have negative 1 plus 4, which is 3. Negative 2 minus 5, which is negative 5. And I like to actually have the negative on top, so I'm going to make this negative 3/5. Does it matter? No. 3 over negative 5 or negative 3 over 5, or for that matter, negative 3 over 5, where you put it in the middle, it doesn't matter. So whether you put the negative sign on top, in the middle, or on the bottom, it's the same problem here. So I just like it where the negative is either on top or in the middle, not necessarily in the denominator. So this is going to be my m, all right? So what I'm going to do here is I'm going to write it as y equals negative 3/5 x plus b, but I still have to solve for my b. So I need to choose one of these points, and I think I will just use my 2, negative 1 right here. So I'm going to use the 2, and I'm going to plug that in for x, and then I'm going to use the negative 1 and plug that in for y. So I kind of color coordinate that for you. Let's do this. So y is negative 1, so negative 1 equals negative 3/5 times negative 2 plus b. All we got to do now is use our sweet algebra skills to solve for b here. So negative 1 equals negative 3 times negative 2. That would give us a positive 6 all over 5 plus b. We're going to subtract 6/5 from both sides. So those guys are gone. And I'm going to come over here and do this. So we have negative 1 minus 6/5. All right. So we'll need to make this guy a fifth as well, which means I have to multiply that by 5. So negative 5 minus 6, which is negative 11/5. Awesome. So I have my m, I have my b, so now I can finally write my equation. So negative 3/5 x, and then our b right here is negative 11 over 5. And that should do it.